So guys, we're gonna continue with this other part of the paper. Question 4 onwards, complete the electronic configuration of copper atom. So copper is basically atomic number 29. So 1s2, 2s2, 2p6, that is almost like 10 electrons. Then it's going to be 3s2, 3p6. You can add 4s1 if you want, but I'll just do 3d, 10, and then 4s1. We know why it happens, right? A fully filled D subshell adds more stability. We know this, right? Explain why copper 2 salts are colored. So we know the whole idea के d orbitals split into two levels, and that is going to be, if you remember, three of them got separated from the other two, and that's like EG and T2G wala na. Unpaired electrons absorb light wavelength and jump from lower level orbitals to higher level by absorbing energy, which is equals to delta E value, and then eventually we end up mentioning K. This imparts color. So we have this one electron. Copper 2 salts are colored na. So copper 2 salts basically mean that they have unpaired electrons over here. That should be it. That should be it. Suggest why copper 1 salts are usually white. So copper 1 ka configuration, if you notice, you will just remove one electron from here na. So configuration will be this, like this. There is no unpaired electron over here. So, sorry. There is no unpaired electron over here. So you can just simply mention K. All the orbitals are full. All orbitals in D subshell are fully filled. No unpaired electron. Brass is an alloy of copper and zinc. The following reaction can be used to determine the amount of copper in a sample of brass. The procedure was carried out using the following steps. A solution of copper 2 ions was obtained by dissolving 1.50 gram of brass in a concentrated sulfuric acid. This is the mass. An excess of iodide ions was added. The iodine produced, it means all the copper ions made iodine with a 2:1 ratio. The iodine produced was titrated against 0.500 mole solution of thiosulfate ions. The volume of thiosulfate is given. Acha, so सबसे पहले I'll find the moles of thiosulfate ions. That is going to be equal to 28.35 exponent minus 3 times the concentration, which is 0.500. Sorry, 0.500. Let's use a calcu. 28.35 exponent minus 3 times 0.5. So that's 1.418 exponent minus 2. 1.418 exponent minus 2. This is the mole thiosulfate. Now you can notice 2 mole neutralize 1 mole iodine. Is that correct? And also we know that in thiosulfate, iodine and copper 2:1:2 ratio is applied. So between thiosulfate and copper, it is a 2:2 ratio. So it's 1:1 basically. So mole of copper ion is also equals to 1.418 exponent minus 2 mole. Now we have to find the mass. So mass of copper is equals to 1.418, which is basically your mole, um, times the atomic mass. Atomic mass of copper is 1.418 exponent minus 2 times 63.5, which is atomic mass. So कर लेते हैं 63.5, that is 0.900 grams. Mass is equals to 0.9001 grams. Percentage is equals to 0.900 divided by 1.50. So I'll divide this by 1.5. My percentage is basically times 100. 60.01%, because there's an exponent 1. Moving on. Use the standard electrode potential from the data booklet to calculate E cell for the reaction. So you can see that copper is going from 2 till 1. It means copper wala jo equation hai, it is moving forward. And jo obviously other equation hai wo reverse hoga. So iodide wala equation, which like this equation that works like this, basically it has been reversed. So reduction potential of copper 2 plus minus reduction potential of iodine is equals to E cell. I'll just go quickly and check the values. Split screen. Copper will be somewhere here. ये रहा 2 से 1 वाला, तो 0.15, and iodine का I ये रहा 0.54 minus 0.54. So basically minus 0.39, which is not a stable reaction, minus 0.39. I don't know why it is even possible. Acha, sorry, they are mentioning this. So by E cell value is negative. E cell is negative, which means not feasible, which means non-spontaneous. In an experiment, a solution of iodine ion is added to solution of copper 2 plus ions. A reaction does occur and a precipitate of sparingly soluble copper ion is formed. The concentration of copper ions in the solution is 1 mole per dmq. The concentration of copper plus 1 aqueous in a saturated solution is 1.3 exponent minus 6. Okay, so if a precipitate is made, it means copper 1 ion concentration is more than 1.3 exponent minus 6. Otherwise PPT would not have been made ना, solubility से ज़्यादा होगा तभी तो हो रहा है. Use the Nernst equation to calculate the electrode potential. Okay, so what's the Nernst equation? The Nernst equation is E cell is equals to standard E cell, not standard E cell, sorry, I mean standard electrode potential, and then plus 0.0592 divided by number of electrons transferred, which is also called as Z, and then we put the oxidized species divided by reduced species. So oxidized species is copper 2 plus, and reduced species is this one. So oxidized species is how much? 1.0 exponent, no exponent, and reduced species is copper 1, so 1.3 exponent minus 6. So let's find it out. The value for copper is 1.15 na, so 0.15 hai, by the way. We'll go back to our calculator. 0.15 plus 0.0592. There's no need for putting it. There was a log here also. Times log, and then 1.3 exponent minus 6, and then square brackets. So there's 0.498 for me, 0.4985. 0.4985 becomes 9, by the way. 1.498 is also okay. 0.498. Copper chloride is also sparingly soluble in water, suggests why the following reaction does not occur over here. In this reaction, you're kind of oxidizing chloride ions, and you're kind of reducing copper 2 plus ions. Maybe this reaction is not possible. I'm just assuming because copper 2 plus ions cannot oxidize chloride ions. I'll go back and check, because chloride is not very easily, it can't be oxidized that easily. Chloride का value उठाते हैं. Chloride का value Cl ना. This is Cr. ये रहा. It's very positive, यार. It's very positive. 1.36. So copper वाले का reduction potential था only 0.15. But chlorine का electron gain करने का potential है 1.36. So chloride ions cannot be oxidized by copper 2 plus ions, as the E cell would be very negative. If you try to reverse it, if we reverse it, then 0.15 minus 1.36 would be very negative, and that's why this reaction is not possible. When chloride ions are added to a solution containing copper 2 ions, the complex ion copper tetrachloro is formed. State the colors of copper. So this is basically blue color. We know this क्योंकि the complex is made by 6 water molecules as ligands. And tetrachloro का तो we know कि it is yellow green. Yellow लिख दो, but साथ में green लिखना है तो लिख लो. Name the type of reaction that occurs when copper chloride. So let's say ligand exchange reaction. Write an expression for the stability constant. The stability constant के अंदर your product comes on top. I always put 2 square brackets. Then your OG is gonna be copper 2 plus, and then it's gonna be chloride ions 4 times. Units are gonna be mole per dm cube on top and mole per dm cube with a mole per dm cube. So that cancels each other. It's gonna be mole inverse dm3. Methyl 2 cyanoprop 2 inoate W is a major component of superglue or rapid setting adhesive. As the adhesive sets, the monomer W polymerizes. Draw a section of the polymer. Acha ji. So it's a polymerization reaction going on. So you have to find out because we have a carbon-carbon double bond over here. Now since we have a carbon-carbon double bond, इसका मतलब है कि we can have multiple of those reacting with each other. So we can simply notice कि if I draw this part without the double bond, I'm just putting this over here as because this is not our major concern. थोड़ा सा angle change कर दिया है. And we have that double H's also ना. So H2 इधर लिख देता हूँ. Now this makes one bond from this side and the other bond from the other side. इसको भी थोड़ा सा angular कर लेते हैं. If it makes one bond from this side and one from the other side, and the second molecule is repeated like this. And now the same thing happens like this. This is what happens. Okay, name the type of polymerization occurring. So that's addition polymerization. Suggest two types of intermolecular forces that could occur between the superglue polymer and the objects glued together. For each type of intermolecular forces, refer to the atoms or groups. अच्छा जी. So I can somewhere somehow see कि भाई यहाँ पे हमारे पास ये partial negative और partial positive वाला एक concept हो सकता है over here. So maybe kind of a PD forces will exist. And you know, we have this carbon atom and oxygen atom and stuff like that. So carbon and oxygen atoms, or you can say carbonyl group. And then obviously one force is always there, which is going to be your ID forces. They're always there. ID forces are there because the carbon chain is there now. So you can simply mention between OCH3 group, or you can like this whole molecule attracting the other side. So carbon chain, basically carbon atoms, or you can simply mention this whole group CO OCH3 CO2CH3 group, because it's a large group, it can attract other groups from the same side. W can be synthesized in 3 steps starting from 2-oxopropanoic acid. Achha ji. Okay, so we have to deconstruct it kind of. We can notice that the major change is here. This is your change 1. And when you remove H and bring the alkyl chain, that's a kind of esterification. So maybe you're doing one of this. Second, you're removing this. O is going away. CN is coming in. So that is change 2. And the third change is the CH3 is going away. I mean, like there's a double bond over here. This is change 3. So what we can do over here, first thing is no nitrogen. There's literally no nitrogen atom. So cyanide is not here right now. Maybe cyanide will be here. Nitrile comes here probably. So if I make this the ester group, let's see. If I keep this same, I'm just counting it. If I make this ester, let's count the atoms. So carbon is 1, 2, 3, 4 carbons. C4 is done. Hydrogen is 3 hydrogens here. 3 is 8, 6 is done. Oxygen 1, 2, 3. O3 is done. So this is done. Now what we can do? The ketone has to go away. This is the ketone. Maybe this is going away and nitrile is coming in. We know how this happens if we do this. What do we call it? Nucleophilic addition with KCN and HCN and stuff. So CH3 remains same. You get OH made out of here, CN made out of here, and then this thing stays the same. And then what we can do is we can remove the OH from here and H from here. So this would be an elimination. Or you can also call it dehydration. Suggest the identities of compound. We have done it. Suitable reagents. So in the very first thing, if you are making an ester with this, you need methanol, because you are reacting methanol to add OCH3 group, and condition would be concentrated sulfuric acid. In step 2, you are adding KCN for sure. So HCN and KCN plus heat. HCN and HCN, sorry. HCN and KCN plus heat. And then what you are doing is you are doing dehydration. So dehydration happens with concentrated sulfuric acid, heat, and concentrated sulfuric acid. The names of many drugs used in medicine often include parts of the names of the functional groups. Suggest 2 functional groups present in a molecule of the drug named chloroamphenicol. So fen से मुझे दिमाग में आ रहा है I don't know why, but fen, I don't know why. But इससे दिमाग में आ रहा है कि maybe there's a phenyl group and chloro group would be there. State the role of ketamine in this reaction. So ketamine is reacting with H plus and it's accepting the H, so maybe it's acting as a base. Acting as a base, that is hydrogen ion acceptor. Ketamine gives an orange precipitate. State the functional group, so that's a carbonyl functional group. You have the M abundance, M plus 1 abundance and M plus 2 abundances here. Acha ji, use a number to show carbon, 13 atoms are here. Acha ji. So we have a very simple formula for this. K 1.1 times N divided by 100 is equals to abundance of M plus 1 peak divided by abundance of M peak, which means N is equals to 14.3 over 100 times 100 over 1.1. This cancels each other. 14.3 divided by 1.1 is 13. N is equals to 13. In addition to carbon and hydrogen atoms, each molecule of ketamine contains one atom of each of the 3 different elements. These are called heteroatoms. One of these heteroatoms is a halogen. Use the figures in the table to suggest the identity of this halogen. Explain your answer. Acha ji. So if I compare this and this, it is a it's a 1:3 ratio. So it has to be chlorine, because you can simply mention K the M and M plus 2 ratio is 3:1. So halogen must be chlorine atom, because if they were same, it would be bromine atom. Another peak in the mass spectrum of ketamine has an mass over charge value of 240. Predict the relative abundance of this peak. Okay, M peak is at 100 and you're getting another peak at a value of 240 over here. So we'll have to find out कि कितना abundance होगा. We know कि they have given some other information. In addition to carbon and hydrogen atoms, each molecule of ketamine contains one of each of the 3 different atoms. These are called heteroatoms. There's no other information over here. We'll have to solve it somehow. और मुझे लगता है n वाला ही फार्मूला लगेगा यहाँ पे तो. So let's find that out. ट्रायल एंड एरर करने में कोई भी मसला नहीं है. I'm just figuring it out. 240. Oh, खुदावंद. It's 240 over here now. Just 239 and 240. So what would be the ratio between them? So it's a very simple thing. You have this as your m peak, तो उसके हिसाब से m+1 निकालना है. If m is equals to 239, m+1 would be 240. उसके हिसाब से निकालना है very simply, and you have the number of carbon atoms also over here. तो इसका abundance is 33.3. तो इसका कितना होगा? We have the formula very simply which we used over here recently. 14.3 over 100 times 100 divided by 1.1. So very simple over here. So 100 divided by 1.1 times, we have the abundance of this peak, which is 239. So 239 comes over here. This m+1 peak का abundance खाली छोड़ दिया, and carbon atoms are 13 in number. So you just simply get your answer like this. Use the information in B for ball. B for ball गया ऊपर. To complete the molecular formula of ketamine by working out the identities of the 3 different heteroatoms and the number of hydrogen atoms present. अच्छा जी, तो we know कि it's a halogen atom for sure. The other 3 heteroatoms are nitrogen and oxygen. They can be present. So moving on, molecular mass, the M peak tells us it's 237. So we can find out how much if it was carbon 13. So 13 carbon is equals to 13 times 12. It's going to be 120 plus 36. So that is 156. 156 is already here. If there is one chlorine atom, then it would be 35.5. But you can't, sorry, not 35.5, just 35, it's mass spectrum question. So that becomes 180, 186, 191. 191 is already here. Then we can do more and more trial and error methods. So one chlorine is here. If one oxygen and one nitrogen are also added, so we add 14 and 16. We had a 16 over here and a 14 over here, so that is a 30. So that becomes, if we keep on adding, 190 plus 30 becomes 221. And then we have to reach 237. So 237 would be how much? Some more hydrogens. So let's put it here in the calculator and then we'll get the answer. If we have 13 carbons, so that is 156. If we have one chlorine, so that is 35. If we have one oxygen, if we have one nitrogen even, so that is 221. If we subtract 237 from it, we get 16. We have 16 hydrogens, which is okay with 13 carbons, which is very much reasonable. So we put 16 hydrogens, one nitrogen, one oxygen, one chlorine. Even then, we are good to go. Naramyxane is another ring, such as the number of peaks in the carbon 13 NMR. We get one peak here, A. This is going to be B. This is going to be C. This is going to be D. This is going to be E. This is going to be F. A, B, C, D, E, F. That's going to be 6 peaks. Number of protons responsible. अच्छा, splitting pattern का बात हो रहा है. CdCl3, which is a solvent, shows 5 different peaks. Okay. What I'll do is I'll just copy this part. I'll delete this part. I'll make a copy here for this. I'll paste all of this here. And for this one, I'll just put hydrogens. So this is CH3. This is 2 hydrogens here, 2 hydrogens here. This is a CH3. This is a CH3, 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 and these are hydrogens. They are mentioning 5 different peaks. So we get a one peak over here, and obviously NH2 will always make a singlet. So you get a singlet here as a broad singlet. NH2 is a hydrogen bonded group. It's a hydrogen bonded group. So you get a singlet because of this. Complete the table. Okay, we have to complete the table only. So 0.9 and singlet peak. 0.9 is mostly because of alkanes, which are CH3 groups. So number of protons responsible for this. So we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 proton responsible for this peak for sure. Then we have number of proton responsible, 3 protons. Where do we have 3 protons for this? Acha ji, we have 3 protons here. So this is this one, theek hai ji. And how much spectrum will I get? There is next carbon has no hydrogens on it, so singlet. There's no proton on adjacent carbon, so it gets a singlet. And then we have 2 protons responsible. So when do we have 2 protons? These are the 2 protons. And these protons are attached to this carbon, this carbon, this carbon. The adjacent one has no proton on them. So that is again a singlet. Because you can see this carbon are adjacent and they have no protons. Per 4. 4 is because of this. But if you notice, they are attached on this carbon, and barabar wala carbon has no adjacent, like there's no proton on the adjacent carbon. So again, this is also a singlet. And we have this NH2. So NH2 mein there are 2 protons responsible because of the NH2 group. Let's go back to complete this table. NH2 wale ka we get spectrum at 2.2 because of the hydrogen bonding. There's a broad spectrum. You are getting 3 protons responsible at 1.2. The 3 protons were this one, CH3. So 1.2 is because of this they have mentioned. You have 4 proton responsible at 1.7. So this is 1.7 wala peak. At CH2, at the bottom, you have 2 proton responsible. 2 protons are at 1.4. 2 protons are at 1.4. So at the bottom, it is 1.4. And all these CH3s are identical, and the 12 proton peak was at 0.9. So this is 0.9. One of the peaks in the proton NMR disappears when the sample is shaken. Identify the peak. That is NH2 protons, as they will exchange with an atom of D. With an atom of D from D2O medium. Ethane, let me see if we have more questions. We'll take up. Actually, this is the last question. We can continue. Ethane dioyl chloride is a useful reagent in organic synthesis. It can be made from compound A in one step. Very simple. Only carboxylic acids make it. So, bhai, ek kaam karo. Ethane and draw 2 carbons and make ethane dioic acid. Suggest the identity. ठीक है. State the reagents and conditions. So we need, very simply, PCl5 is enough for it. Benzene in step 1 gets 1 chlorine. So very simple, make a benzene and attach one chlorine. In step 3, you are making NH2. You can't add NH2 directly, you have to add nitro group first. In step 2, you are doubling the chlorine, but you are using this. Acha ji. So what happens is you will get this as your intermediate and you will get AlCl4. So you will attach this on this, but which carbon? So chlorine is a 3 carbon wala, chlorine is a 3 director. So draw this, but on the carbon number 1, 2, 3, chlorine is lone pair. Chlorine has lone pairs. So chlorine is also a 4 director. 2 4 director, by the way. Also फाइनल पिक्चर दिया हुआ है ना, फाइनल पिक्चर को भी कंसिडर करो ना. फाइनल पिक्चर में 4th पे अटैचमेंट हो रही है, तो 4th पे अटैचमेंट करो, कार्बन लगाओ, हैव योर डबल बॉन्डेड ऑक्सीजन, have your other carbon with a double bond oxygen and have your Cl. In D, अच्छा D becomes NH2, that is for sure. ठीक है, आगे क्या हो रहा है? They are connecting both of them. Okay. So if they're connecting both of them, इसका मतलब हुआ कि this group will go elimination and the NH2 group will come with its lone pair. So let me draw it. Just for the sake of this picture, ये as it is, Cl as it is, double bonded oxygen, the Cl will go away. And when the Cl goes away, the nitrogen comes in. One of the hydrogen has also eliminated, so HCl will eliminate. And then this. And then what you are doing in step 6, you are making it an alcohol and you are removing this also. Probably a reduction is going on. In step 1, I am adding AlCl3 for sure and chlorine. That is called electrophilic substitution. In step 3, what am I doing? I'm adding NO2. So that is concentrated nitric acid and sulfuric acid. Again, that is an electrophilic substitution. In step 4, step 4 I'm making NH2 now. So that is reduction. I'm using tin and concentrated hydrochloric acid, and that is reduction. In step 6, what am I adding? I'm just making sure reduction is going on. So that is lithium aluminium tetrahydride in dry ether, and that is again reduction. If the amount of CuCl used in step 2 is decreased, another compound is formed in step 2 with the molecular formula C14H8O2Cl2. Suggest the structure. अच्छा कम कर दिया in step 2 में. If I lower the amount of this in step 2, what is possible? If I'm lowering the amount, maybe in this case, I can add the number of atoms also, but let's look at the structure of this also. Okay, if this molecule is lesser in amount, अगर मैं दोनों chlorine हटा देता हूँ इसके, because if the amount is lesser, then both chlorines go away. हाँ सही है. Then both chlorines will be eliminated like this and like this. So you get a positive charge on both carbons. So both carbons get a kind of substitution happening on them, and both carbon will get a benzene ring जिस पे क्लोरीन पहले से लगा हुआ था. Identify all the steps in synthesis of Q from benzene that are electrophilic substitution reaction. We have seen that uh, 1 was substitution, 3 was substitution for sure, and when I look at the other steps, 2 was also kind of substitution, बताया नहीं इन्होंने, but सही है, 1, 2 and 3, बाकी तो reduction थे. Okay, so this molecule they are heating with dichromate in the beginning. If I heat it with dichromate, let me just copy this part. Hey, why did it not copy? What happens is, I will simply make it a ketone group over here. Let me use some other pen so you know what's changing. That's oxidation. If I heat it with sodium hydroxide, so sodium hydroxide is going to act as an alkali, but alcohol hai na, there's no reaction going on, no acidic group. If I add bromine, so bromine will be attached here, so carbon number 2 4 6 पे आ जाएगा, so 2 पे bromine, 4 पे bromine, 6 पे bromine. HCl at room temperature. If I add HCl, so this is like a basic group, so you will have, इस पे आ जाएगा H2, ये हो जाएगा नाइट्रोजन हो जाएगा प्लस, and then you'll have a Cl as negative ion. That's it. I guess we're done. Stay tuned guys for more papers. Bye.